All right. So in this problem, we will perform another index shift or power shift to the following power series so that it would start at n is equals to 5 instead of n is equals to 3, right? So just as we have done from the previous video, we will let the variables n to have another variable, say I, and express I to make an equivalency to n is equals to 3. Now I would do that by letting I is equals to n plus 2. I did that because if I let values of n is equals to 3, then I would be equal to 5. So n plus 2 is 3 plus 2, which is 5. So with this equivalency, I can replace n is equal to 3 with I is equals to 5. So another relationship from this one, from the definition I is equals to n minus 2, n should be I minus 2, so that we could replace all of the values or the variables n from the power series itself. So let's first start by changing our index. So that's gonna be I is equals to 5. Then we have n, which is now I minus 2, that's squared. And then with power series coefficients a sub n, where n again is I minus 2. Then let us not forget the minus 1 there. And then x plus 4, n plus 2 is I minus 2 plus 2. Right, now evaluating all the changes, uh, that's I plus 2, nothing there. And then here, negative 2 minus 1, that's maybe minus 3. And then we have x plus 4. Okay, so negative 2 plus 2 is 0, so it's going to be I, right? So finally, since this is I is a variable and really have no explicit meaning unless it would be related to other components, we can easily change it to any other variable that we want. Could be A, could be B, C, or any alphabet. But in order to make it consistent with our instruction that it should be n is equals to 5, then let's just use n. So squared n minus 3 x plus 4 raised to n. And that's our shifted power series. Now take note that uh, when doing index shift or power shifts, uh, it it's really not necessarily, or this one is how you actually do it, but there's a pattern where you can use without doing this. So the pattern that you need to realize is that if you add or subtract anything from your index, you have to make the same magnitude uh, and I mean opposite to the other parts of the power series. So we have two components that we need to change, the index and the power series, right? So if you add something to the index, you had you have to subtract by the same value to the power series. Alternately, if you minus or subtract something from the index, then you have to add something from the power series. And let's just do that without having to define the variable here. So let's copy the same problem and continue with another one. But now let's follow that principle I just mentioned. So uh, let's write first the infinity and then n. Okay, so from our instruction, our n should be a 5, should be 5, right? So what I need to do is, in order for this to make 5, I would add, sorry, I would add 2 to make this start at n is equals to 5. So similarly, from what I have just told you, you need to do the opposite for the power series. So if you made an addition on the index, you have to make a subtraction on the power series. So that's minus by the same magnitude. So that's 2. And that's for all. Then here you have a n minus 1. But then you have 2 again minus 2. And then you have 1 under, which is n plus 2. So n plus 2. And you also have to subtract from this part by the same magnitude. So doing so and performing the necessary arithmetic, so that's 3 plus 2 is 5, then n, sorry, this is squared, n minus 2 squared, a sub negative 1 minus 2 is 3, and that's x plus 4 raised to n. So let's see if it's the same. Indeed, right? So the rule is simple. You add something from the index, you subtract on the power series. You subtract something from the index, and then you add something to the power series by the same magnitude that you have added or subtracted from the index. Okay, you can try example number 1 and see if it indeed returned the same result. All right.